Hello everybody, this is me, Gabriel, and today I'm gonna teach you how to run Python MIP code on Apple Silicon. The reason why I'm making this video is because I'm currently doing a class on college where I need to run this MIP code. I think in English it's called like operational research, if I recall correctly. So you would use something like the MIP library, and you would think that when you come here and put something like pip install MIP, it would just install. But hey, no, it's gonna give you a lot of errors. So first things first, how to get like MIP installed, because that's already like it's funny because every single step of this process is just currently totally broken. What you're gonna want to do is to actually open any terminal, really, like can be this one here, and just do pip install MIP, and then you're gonna do like equals 1.14.0. The current version, I think it's 1.14.2. So this is like a little bit older than the current one, but this part here is not only a problem in macOS, but it's also a problem in Windows and in Linux, just because pip is currently broken with this package. So first you're gonna run this to install MIP. So this is not gonna give you any errors. I already tried it in macOS, Ubuntu, and Windows, so it works on all three systems. I'm not gonna run it because it's already installed on my system. Now that we've done this, I'm gonna actually delete this. So the only way that I actually found to be able to run the MIP code here, you can see that I'm using a Apple M2. So the only way that I found to actually get to run this MIP code was to come to this Japanese website where they actually teach you how to do this in M1/M2. I believe that this will also work on M3. There's no reason for it not to work on M3. I'm currently on M2, so this should work with any Apple Silicon processor. So after you install MIP, the next step is to actually follow these instructions here. I'm gonna leave a link to this website, and like you can ignore this step here because this is for Ubuntu. However, it's good that you have Homebrew installed on your system. So like if you don't have just Homebrew, macOS, and come here and run this line here on your terminal. Alright, so if you already have that, also please do Homebrew install bash, because you're gonna need bash in order to run this. You also need to install like GCC and Git, but you already probably have that installed if you're already a programmer at this point. So let's start actually by this step here. So mkdir and do this. And now you're gonna do the next step, which is to get this package here, which is coinbrew. Coinbrew is actually a package that's made for you to compile CBC. Because if you actually try to run this code on a Apple Silicon computer, it's gonna give you an error saying that CBC dot something is not on your computer. So that means that the CBC library is not compiled for ARM. For some reason, they only compiled it for x86 on the Python MIP or MIP, this thing. So just run this command here. It's gonna fetch all the necessary files. It's gonna take a little bit for it to run. So yeah, well, so this process finished now, and you would think that the next step would be for you to come here and run this command, but no, it's not. Well, you could do that, but it's actually taking you to a folder called Haroldo, which I'm pretty sure it's not what you want. So I actually want to scroll down here to where it says, well, it's this one. So it's like bash coinbrew build cbc master no prompt prefix. It's not gonna be like Haroldo stuff. So yeah, it's also cool thing, it's gonna compile with like parallel options, so it's actually gonna give you a better performance for like comparing to not compiling it yourself. So I just copied that line, and now you press enter. So you also want to install this package here before you run this command, because otherwise it's gonna give you an error. But it's okay, just if you have any errors, just install the necessary packages. But yeah, okay, so after you install all the necessary packages, just run this command here, which I copied from this part. Please do not copy from this part here. Scroll down and copy from this part. I'm actually gonna leave like all the commands that you'll need on the description, on the video description. Okay, so after you compile the whole thing, which is gonna take like 2 to 3 to 4 to 5 minutes depending on your configuration. Okay, so for the final step you actually want to do nano and then tilde. Well, how do I do tilde on this keyboard? Crap. Okay, it's this one. Alright, so slash and dot and zs hrc, and I already wrote it here, but I'm just gonna show you like how we would do this. So just come here and copy this line, which is gonna like put the compiled file into the imp-cbc library. Then you're gonna press Command V here, which is gonna paste that line there. Of course, I'm gonna erase this here because I already have it there. So in my keyboard, which is a Windows keyboard, I would press Control O. I don't have a Apple keyboard, so I don't necessarily know like what's the key for that, but like if you were using a Windows keyboard, you would press Control O and then press Enter and then press Control X. And remember, this control key that I'm mentioning is on the Windows keyboard. I'm pretty sure the Apple keyboard has like different names, but I don't have one, so I don't know how it's called there. And I'll just run this last step here. So paste it on your terminal and execute that. Yeah, it's gonna tell me that there's no current job here, but it's probably gonna update on yours because in my case I didn't have anything different there. Okay, so after you do all of this, after you manage to get here, you can close this. I'm actually gonna close. So let's actually run this script here and let's actually run it. Hey, nice. So it ran, and just take a look at how fast it ran. Like, let's pick another one. Like, this is like extremely freaking fast, guys. And the reason for why this is so fast is because you actually compiled the source code yourself, so it's gonna be extremely optimized on your machine. Not only that, but on this step here, you actually enabled the parallel option for the CBC library. So it's actually gonna use like all the threads in your CPU, and that's gonna be way faster compared to the default CBC that is mono thread on macOS. So there's actually an advantage for you doing this, even if you're watching this video in the future and you don't need to do this. So like if you want to see like how to compile CBC and use it on Python MIP on macOS, you can also follow the video for that, because it's gonna be way faster than using the default CBC. But yeah, the video is gonna end here. Thank you for watching. Hope it was helpful to you. See you next time. Bye bye.